Zen Fluidics Flow Control Unit comes with two operating modes. The first one is to use the device as a pressure controller. Here, the user manually adjusts the pressure differential and consequently the flow, which is still subject to the hydraulic resistance of its path. The second operation mode utilizes a microfluidic flow sensor that feeds the flow in real time to the unit for it to continuously adjust the pressure needed to keep a constant flow selected by the user. Let's do an example to calculate hydraulic resistance. In this exercise, we have a circular tube of 250 micrometers in internal diameter and 150 millimeters in length. We wish to achieve the following conditions: constant flow at 2000 microliters per minute, a 15 microliter per minute step control, and a maximum of 2500 microliters per minute. For this case, we will use a sensor with an upper and lower limit of 5000 microliters per minute to cover the range that we will be working with. If we simply run the experiment, you'll notice that it is impossible to get to the desired flow. By means of pressure control, the flow will be too high, way past the sensor's range. By means of flow control, the system oscillates and can be controlled or stabilized in the desired flow. We can confirm this with the calculator embedded in the Zen Fluidics software. Click on the Zen Fluidics icon and in the Applications tab, select Microfluidic Calculator. In the calculator, we can select between two types of geometries to calculate the expected flow of the system. In case we have a circular geometry, we have characteristics such as diameter and tube length. In the case of a square geometry, we have width, height, and length of the tube. For this example, we will be using circular geometry. Then, we write the diameter of the tube in micrometers and the length in millimeters. The next step is to select the system parameters. Here, we take into account the density and viscosity of the fluid that we will be working with. In this case, it's distilled water. The next parameter is the pressure we wish to apply. As we mentioned in the tutorial, the Zen Fluidics Flow Control Unit works in a range of -500 to 1000 millibar. Input 1 millibar for this example. The result shown in the calculator is 61.36 microliters per minute. This means that each millibar we apply to the system, the flow increases 61.36 microliters per minute. This also means that if we want to have a 15 microliter per minute control, this configuration will not be sufficient. To correct this problem, we can do the following: change the internal diameter of the tubing, change the length of the tubing, or connect the flow restrictor in series with the right parameters. The flow restrictor or resistance is a capillary whose hydraulic resistance is selected to maximize the system's stability. This helps reduce the sensibility to noise from external pressures or vibrations. Usually, the tubes have an internal diameter of 500 micrometers, 250 micrometers, 100 micrometers, 65 micrometers, or 25 micrometers. Going back to our example, this time we will use a restrictor with an internal radius of 127 micrometers and a length of 86 millimeters to achieve better results. From our calculations, we get 7.13 microliters per minute for each bar we apply with the restrictor. Since we are below the 15 microliter per minute limit, we will be able to control the system as desired. To better appreciate the impact the radius of the tube has over the flow, we can apply 300 millibar to the system with a 500 micrometer diameter tube. The system easily goes over our desired limit of 2500 microliter per minute, and it even goes beyond the measuring capacity of its sensor. On the other hand, if we use a 254 micrometer diameter tube as our resistance, we stabilize the system. With the resistance, we also get a wider range of working values in case we need them. In conclusion, The use of a flow restrictor can adjust the working values to the ideal values for a given assay, from picoliters to milliliters per minute. The selection of the flow restrictor depends on the overall resistance of the system, which may include additional components to the ones shown in this tutorial, such as interconnecting components, microfluidic chips, sensors, and several others. Many times, it's hard to know the hydraulic resistance of a microfluidic chip or a complete system. Given this, we suggest the following values of lengths and diameters to help you get a general idea of how to calibrate your setup. Additionally, keep in mind the following recommendations as they might facilitate the selection of the restrictor and the flow sensor. First of all, estimate the hydraulic resistance of the system. We recommend using the Zen Fluidics Calculator. In some cases, the calculations can be simplified. We also recommend getting to the desired flow rate using only a quarter of the maximum pressure of the Zen Fluidics flow control unit, that is about 200 and 250 millibar. This way, there is always room to readjust the pressure to wash the system or compensate for higher resistance than expected. Third, choose a sensor with at least 3 or 4 times the capacity of the flow that you will be working with. We do not recommend going higher than this, since the sensor will lose resolution and increment the error for each reading. Do not over-tighten the microfluidic connectors, since this may compress the tubing and generate additional resistance.